All right, today we're going to go over how to solve and graph compound inequalities, and along with that, we're going to introduce interval notation. Interval notation is another way to show your answer to an inequality. So there's two types of compound inequality problems. One is an AND problem, x is greater than 1 and x is less than 5. The other one is an OR problem. This one says x is less than or equal to 1 or x is greater than or equal to 5. It's really important we understand the difference between these, between AND and OR. A really quick example, that I was given this example in class one time. So let's say that you want to get married, and when you get married, you want to marry someone who is rich and good looking. Well, that means there's some rich people out there, but amongst the rich people, they're not all good looking, right? You want them to be rich and good looking. They have to be both. That's going to be pretty tough to find. It's a very small pool, right? Now compare that to OR. If you say, I want to marry someone that is rich or good looking, well, that means you'd be happy if they were rich. You'd be happy if they were good looking. You'd be happy if they were both. But it includes all the people from both of them. So if you think of AND and OR, the difference is AND, it has to be true of both. So it has to be greater than 1 and less than 5. So when we graph that, x is greater than 1 would be right here, right? It's an open dot because there's no equal sign, and it's going that way. And x is less than 5 would be right here, again, open dot, and it's going that way. Well, for the final solution, it has to be true for both. So even though up here, right, 6, 7, 8, that's true for the first one, it's not true for the second one, so it would not be part of our answer. Or over here, all these numbers are true for the second one, right? They're true for that one, but not the first one. The only part that's true for both would be between 1 and 5. So my actual answer, if I combine those, and we can write those together like this, we say put the 1 here, put the 5 here, put the x in the middle. X has to be greater than 1, but smaller than 5. So this is how you'd write that answer. There's another way to also write these answers, and this is the interval notation. So with the interval notation, instead of using an open circle or a closed circle, we use a parenthesis and a bracket. So an open circle, we always use a parenthesis. It could be facing to the right or to the left. With a closed circle, we always use a bracket. Again, it could be facing to the right or to the left. So if I wanted to graph this, my answer from 1 to 5, all the numbers between 1 and 5, I would start out, I'm going to erase this, I'm going to go like this. It starts at 1, and it's opening to the right, so I have my parenthesis open to the right, and it goes to 5, and then I shade everywhere in between. So what that means, again, is it includes everything between 1 and 5, not including 1, not including 5. So that's how you can graph it using that parentheses brackets, that interval notation. The way you write the final answer is actually, you always go from left to right. So as I go across that number line, right, if I'm going to go across there, my answer doesn't start until I get to 1, and it's a parenthesis because it doesn't include it. And my answers go until I get to 5. So these two answers are the same thing. Okay, they mean the same thing. Okay, let's do an OR problem. So if I come up here, has x is less than or equal to 1. So let's do that one. Do that one in blue. So I'm going to go to 1. It's got the equal sign, so I'm going to do a closed dot. X is less than or equal to 1. That means I'm going to be open to the left. Or x is greater than or equal to 5. So it can equal 5, greater than. And with OR, you include them both. If this were an AND problem, then there would be no solution because AND it has to be true for both. And there are no numbers that are less than 1 and also greater than 5. But for an OR, it's okay. We just include them both. So I'm happy with the numbers from 1 to negative infinity. I'm happy with numbers from 5 and going to the right. I'm happy with both of them. So the way you write that with interval notation is like this. This is a little bit tricky. So it starts at, think of your line again. You always start on the left side. So where does it start over here? Well, it goes that way forever. And then it goes until I get to 1. At 1, it's included. So what I do, remember up above we said if it's a closed dot, we do a bracket. So I do a bracket, and I want it to open the way that it's going. Okay, so it's going that way. Then it starts again at 5. And again, I want it to open the way that it's going. So the way you'd write this answer with interval notation is I start from the left side. It starts at negative infinity. All that means is it goes to the left forever. And it goes until I get to 1. At 1 it stops. So 1's where it stops. I put a square bracket. It doesn't start again. There are no more answers until I get to 5. So over here I put a square bracket. It starts again at 5. And it goes until you get to, well, it goes forever. So it goes to infinity. In between there we put a union sign. That union sign just means it includes both of those answers. So this is my answer and that's my, or they're both my answers. So a little bit tricky. We're adding in this idea of compound inequalities. We're also adding in the idea of this interval notation, just a different way to write our solutions. I want you guys to try this one. So pause this one for a second. I want you to graph it and then write what the answer is. And then I'll come back and unpause it and I'll go through it with you. All right, so I'm going to start with x is greater than 3. So if that's 0, 1, 2, 3, 4, 5, 6, 7, we have to go at least to there. X is greater than 3. I'm going to start with that. It's an open circle, and it's going that way. X is greater than 3. And x is less than or equal to 7. So let me do that a different color. I'm going to go to 7, which is right there. This one's a closed dot, and it's going to include all the answers going back that way. Now, because it's an and, we only want the ones that work for both. So I'm going to do one more color here. The ones that work for both would be from here to here. Everywhere in between there, it's true for both of them. So my actual answer, I'm going to write this way. This is going to be a parenthesis. This is going to be a bracket. Parenthesis because of the open dot, bracket because of the closed dot. So my answer starts at 3, and it goes until I get to 7. You could also write it this way, and this is fine. You could put when you have these that include both of them, they're between 2 points. If your answer is ever between 2 numbers, you can go like this. Put the 3 on that side, put the 7 on that side, and x has to be greater than 3, less than or equal to 7. That would also be fine. So you could write it this way, or you can write it that way. We're going to skip past that one. Now what happens a lot of times is you actually have to solve these inequalities. So if you look at this one, I've got to solve both of these to find my answers. Let's do a couple of those. We're going to start that first one, and we've done this before. Just do each one separate. So you see the or right there? Just do this inequality over here first. So that's not hard to do, right? I'm just going to minus the 8, minus 8, minus 8. So those cancel out. R is less than 14 minus 8 is 6. Okay, over here on this side, or R over 10 is greater than 1. Make sure you times by 10, right? Times by 10. So we get R is greater than 1 times 10 is 10. So there's my problem. I can write the answer as being R is less than 6 or R is greater than 10. And then down here I'm going to graph it. So I'm going to go to 6, and R is less than 6. I'm going to use parentheses or brackets here. So less than are all the numbers going this way. So it's going to be a parenthesis to the left. That's R is less than 6. Or R is greater than 10. So I'm going to go to 10. Again, there's no equal sign, so it's a parenthesis. And I want the numbers that are bigger than. So it's open to the right that way. So that's what my graph will look like. If I'm writing the answer using inequality notation, I just leave it just how it is. R is less than 6, or R is greater than 10. If I want to write it with interval notation, I start from the left. So over here on the left side, right, where does it start over here? Well, it goes to negative infinity. So it goes negative infinity, comma, and my answer is go until I get to 6. That's where they stop at. Union sign. And then it starts again at 10, and it goes to infinity. Let's get past the or. Let's find one that's an and. So when you have an and problem, a lot of times they take them and sandwich them together. So when you see a problem like this, where there's 3 parts. I have a middle, then I have a right side and a left side. That just means it's really an and problem. So let's take this. I'm going to rewrite it down here. We're going to go through and solve this. So 18 is less than or equal to 6k, which is less than or equal to 24. So when you go through and solve this, I still want to get k by itself right there. So it's 6 times k. I'm going to divide by 6. This is the tricky part. is really you have two inequalities put together. So I have to divide 6 on that side of the inequality, but I also have to divide 6 on that side of the inequality. So 18 divided by 6 is 3. K divided by K is 1. 1K is K. And 24 divided by 6 is 4. So let's graph what that looks like. So what that really means is K is bigger than 3, but smaller than 4. That just means it's between 3 and 4. So I'm going to come up here, and they do have equal sign. So K is between 3 and 4. It just fits between there. If you're writing it with inequality notation, that's your answer right there. You've got it. You don't have to do anything else. If you write it with interval notation, you start from the left side. So it starts at 3. It includes everything between 3 and, the answer is and at 4. And there's the sign on the opposite side. That's pretty much all there is to this. That's another OR problem. Let's do this last OR problem right here. This one's a little bit tricky because I just want to remind you of something. So I'm going to start this first one. Let's solve that first inequality. So it's -5 times n. I've got to divide by -5. Just don't forget all the stuff we've learned about inequalities. If I divide both sides by a negative like I just did, make sure you flip the inequality sign. So instead of being a greater than, it changes to a less than. -45 divided by -5 is 9. Or, let's bring down the other one. N minus 10 is greater than 0, so I add that 10 over. So, or n is greater than 10. Okay, let's graph this one and see what it looks like. So I come up, n is less than or equal to 9. It's got less than or equal to, so it's got the equal sign. That means it'd be a closed dot or a square bracket, and it's less than 9. And n is greater than 10. That would normally be an open dot or a parenthesis, and it's greater than 10. So it's going that way. So if you look at it, that would be my answer with inequality notation. But writing with the interval notation, start from the left side. It goes to the left forever, negative infinity, and goes until I get to 9. It is equal at 9, so it'd be a square bracket. Union, that just means it includes both of these. So it also includes 10 to infinity going that direction. And we're done. There's our answer with the interval notation. Let's do this last problem here. So I've got 3x plus 10 is less than 4. Let's solve that. So 3x plus 10 is less than 4. So I'm going to minus the 10 over. 3x is less than -6 divided by 3. X is less than -2. And we'll solve this other one. 7 minus x is less than 15. Be really careful with signs here. I'm going to minus the 7 over first. That negative stays with the x. So negative x, oops, not equals, but is less than 8. That's like having a -1 there. You've got to divide by -1. When you do that, you got to flip that inequality sign. So I've got x is less than -2, x is greater than -8. This is an and problem. So if I take a look at that, I can go to x is less than -2. Here's -2, no equal sign, so I'm going to do a parenthesis. X is less than, so it's opening to the left. So let's go in that direction. And x is greater than 10, or sorry, x is greater than -8. So I go to -8 again, there's no equal sign, so it's a parenthesis. That one's going to the right. Okay, my final answer is the part that's true for both of them. So that's between -8 and -2, and it's just that. So my actual answer itself would only be that part I just drew out in black there. Be the parts between, it has to be true for both. It has to be -8 and greater than -8 and less than -2. Both have to be true. All right, so the answer down here, you would not leave the answer this way with an and. With the and problems, you always combine them together. So I'd write it this way. It's between -8 and -2. It's bigger than -8. It's smaller than -2. That's where you'd write it with inequality notation. With interval notation, you'd say it starts at -8, comma, and includes all these answers until I get to right there, which is -2. These get a little bit tricky. Try the ones on your assignment as you go through. Make sure to keep track of questions you have and let me know, and I can go through and help you figure those out. Thanks, guys.